All right, we're going to look at example 7 and example 8 in chapter 24 now. Let's look at example 7. If x is normally distributed with a mean of 23.6 and a standard deviation of 3.1, find k for which the probability that x is less than k is equal to 0.95. Okay, so let's just draw this. Remember, what are we actually thinking about and looking at? If we draw the normal distribution, we know the mean is here in the middle, so that'll be 23.6, and standard deviation 3.1 on either side. So we could draw those in if you wanted to and put the values, okay? But we're looking for a probability of 0.95 and less than. Remember, we can only do less thans. So if we have a less than, we can go straight to doing that. We're basically looking for all of this area where we only have 5% left up here, and we have 95% in our area that we're looking for. Okay, so we get the calculator out and we say menu, probability, distribution, and normal, no, not normal, inverse normal. Doing the inverse. We're not finding a probability, we're finding a quantile, so we have to use inverse normal. All right, let's get our calculator out and do that. Menu, probability, distribution, inverse normal. The area we're looking for, 95%, so 0.95. The mean, 23.6. The standard deviation, 3.1. Press OK. And 28.7. 28.7. 28.7. So, first of all, does this answer make sense? Should be higher than the mean, shouldn't it? And how many standard deviations higher? More than 1. Okay, so we're in the ballpark. We see that this critically makes sense, this answer. All right, so how do we notate this then? We would say, there's our question. So then we would say inverse norm 0.95, comma, 23.6, comma, 3.1, okay, and then say, therefore, k equals 28.7. All right, that's example 7. Now, example 8. Example 8 is dealing with the standard normal distribution. Still looks exactly the same, doesn't it? Standard normal distribution still looks the same, except we know all the values here. We know this is 0, and we know 1, 2, -1, -2, and so on. All right. If z is a standard normal distribution, find k such that the probability that z is greater than k, okay, that's going to be a problem for us because our calculator can only do less thans. So z is greater than k equals 73%, 0.73. All right. Well, first step is to rewrite this question with a less than, okay? We need to say, okay, probability that z is less than k is going to be how much? 1 subtract the 0.73, so 0.27, okay? These two numbers need to add up to 1, okay? If we're going to start off with a greater than 73%, then that same number is going to have less than of 27%. We can do this. All right, so get our calculators out. Same keystrokes, menu, probability, distribution, inverse norm, because we're finding a quantile, not a probability, 27%, so 0.27. And we're dealing with a z distribution, so we use mean of 0, standard deviation of 1, which are already there for us. Press OK, and negative 0.613. Okay, so our next step here would be inverse normal. 0.2701. Therefore, k equals negative 0.613. All right, now, again, be critical about your solution. Make sure it makes sense. Does it make sense that less than 27%, okay, 27%, so remember this is 34%, this is 13.59%, 2.15, 0.13, so 13, 14, 15, 16% up till here, and we need 27%, but if we went as far as the 0, that would be 50%, so it has to be somewhere in between -1 and 0. Okay, so that totally makes sense. This number is between -1 and 0. Now, the next part of this says, interpret your results. So what this actually means, and another thing that the standard normal distribution does for us, is it tells us that 27% of this data is point 0.613 standard deviations to the left of the mean. We know it's to the left because it's negative. Trying to figure out the right way to word this, but we know it's to the left because it's negative. So we know that 27% of the data is less than 1 standard deviation away from the mean on the left-hand side of that graph. Let's see what they say in the textbook. They say, this means 73% of the Z distribution values are more than this. So I guess they're just wording it. They're just answering this question here. Okay, but remember the Z distribution does tell us how many standard deviations away from the mean we are. So this value of 27% of the data is the value that brings us 0.0613 standard deviations away from the mean, but to the left of the mean because it's negative. Have fun.